Alright, so today we're going to be looking at expressing numbers as a power. In the first example, we've got -2 in brackets to the power of 3 and negative of 2 to the power of 3. We'll note that the exponent of 3 only affects what it's touching. It only affects the -2 in the first example. So -2 to the power of 3 will give us -2 times -2 times -2. -2 to the power of 3 is like saying negative and then 2 times 2 times 2. 3 negative numbers will give us -8. And 2 times 2 times 2 here is also 8 with the negative sign in front. So it turns out that both of them are the same, -8 and -8. Now if we look at it a little differently, something like -3 in brackets to the power of 2 and -3 to the power of 2. We get -3 times -3, and we get, which is equal to +9, and we get -3 times 3, which comes in as -9. The negative stays. Just like it did up here with 2 cubed, the negative stays. With an odd exponent, we have to be careful that the negative signs don't cancel out. With an even exponent, they do. The -3 squared, the negative signs cancel out. Now, what about negative of -2 to the power of 5? If we treat that like we did before, the negative sign will stay in front. Oops. And then we'll have -2 times itself a number of times. So -4 squared. And then -4 to the power of 2, -4 in brackets to the power of 2, and the opposite of -4 to the power of 2. Notice that the negative sign only gets written once. In the second case, exactly the same. The third case, the -4 gets written twice. And in the fourth case, we have a negative sign in front and the -4's get written out. So -16, -16, +16, and -16 again. Now in this case, you may want to pause this after the numbers get written. So we're looking at a table with powers, bases, exponents, repeated multiplication, and a certain value. I would suggest that you pause the video once I've finished writing down the numbers here. We've got 3 squared, a base of 6, an exponent of 5, a repeated multiplication of -2 4 times, a power of -3 to the power of, I believe that's 5, an exponent of 4, and -16. So if you can, pause it and go back. Now, negative and 0 exponents. 2 to the -3, 4 to the 0. Okay, examples of a negative exponent and a 0 exponent. So let's take a look at how those things work. And we're just going to use a pattern here. So I started with 3 cubed. And we knew through repeated multiplication that that was equal to 3 times 3 times 3, which we know is 27. And you've seen this before. 3 squared is equal to 3 times 3, which is equal to 9. 3 to the 1 is just 1 3. We got all that. We get 3 is equal to 3. And notice here how we get to that 9. Another way of thinking about it is the previous number divided by 3. We lost a 3 in 3 squared. I do the same thing for 3 to the 1. I go the previous number divided by 3. So when I do 3 to the 0, I don't know what 3 to the 0 is. It's not automatic. But if I use that pattern of the previous number divided by 3, I'll get 3 divided by 3, which is equal to 1. That must mean that 3 to the 0 is equal to 1. And we can use that same kind of pattern to get negative exponents. 3 to the negative 1, it's not intuitive, we don't know what that is, but if we use the previous number divided by 3, that pattern, 1 divided by 3 comes in as, we can write that as 1/3. That must mean 3 to the negative 1 is equal to 1/3. 3 to the negative 2 would be the previous number divided by 3. 1/3 divided by 3. When we're working with fractions, that's the same as saying 1/3 times the reciprocal of 3. So 1/3 times 1/3, and that comes in as 1/9. So that must mean that 3 to the negative 2 is equal to 1/9. So 3 to the negative 1 is 1/3. 3 to the 1 was 3. 3 to the negative 2 is 1/9. 3 to the 2 is 9. If 3 to the negative 3 is related to 3 cubed, then it should be 1/27. And if we check that out, we get the previous number, 1 divided by 9, or 1/9 times 1/3, we get 1/27. So we're making connections here between positive exponents and negative exponents. 3 to the 2 was 9. 3 to the negative 2 was 1/9. So now let's look at that same pattern with some different numbers. 2 to the 4 all the way down to 2 to the negative 4. And if you take a look at the pattern that's generated there, that will have covered everything that we did.